All right, last video for Unit 4, going to deal with watersheds and then El Nino and La Nina. So first thing with a watershed, I'm just going to give you guys the check for learning right now. Describe the characteristics of a watershed. If you can describe what a watershed is and the characteristics of it already, feel free to fast forward. If you can't though, you should remember that a watershed is going to deal with the slope of the land, the area contained within it, the soil type, and the vegetation. These are all the characteristics because a watershed, if you remember, let's say that I had a stream running through here, and this is a valley. You know, all the land is kind of sloped downward and towards here. And this line here is my ridge line. If you think back, remember when we crumpled up the paper, drew the little marks on it, and then sprayed it with water? That's what a watershed is. It's all the land that drains into a particular body of water. So we need to know what the slope of the land is because that's going to tell us how quickly the water is going to drain out of that watershed. The lower the slope, the more it's going to hold in the water and not allow it to flow. The greater the slope, the more runoff we're going to have, and the quicker it's going to find its way into that body of water. Quicker it finds its way into the body of the water, the less filtration is going to happen because, again, soil naturally filters water as it flows through it. So if I have a very high slope, I'm going to experience a lot of flooding happening in that body of water because the water is not going to be retained. It's just going to drain in very quickly. So if it's flooding constantly, I know I'm also going to have a large input of pollutants if it's a polluted area because the water is not able to soak through the ground and naturally filter. The area encompassed by the watershed is another big one. Larger the area, the higher potential for pollution happening because I have all that area draining water into the same body of water. The odds are in that large massive amount of area, I'm going to have a higher amount of pollution, a higher quantity of pollution happening than I would in a smaller watershed. Soil type again is important because that's going to determine the characteristics of the soil. If it has a lot of sand in it, the water is going to rush right through the soil, raise the water levels every time there's a rain, raise the water level in that body of water associated with it. If it's more of clay soil, the water doesn't soak in. Again, lots of runoff happening. So the soil type impacts it greatly as well. And then vegetation, the more vegetation there is, the slower the water flows down the hill, the less risk of flooding we have. So most of the time you're going to link the water flowing through a watershed to either flooding or flood risk and pollution. Okay, so that's what watersheds are. Again, just going to touch on them basically. But our big part of this video is going to be El Nino and La Nina. And if you remember, these both occur in the equatorial Pacific. And if you remember correctly, not only the equatorial Pacific, but near the coast of Peru. Because again, we had the Peruvian fishermen were the ones that first discovered that El Nino was occurring. It's still a phenomenon. We don't understand why it's happening. We just know how it's happening. So when we look at it, when we have naturally occurring times where it's not an El Nino year, we have very strong trade winds at the equator. Those strong trade winds push the water across the surface of the ocean. As it pushes across the surface of the ocean, again, solar insolation is the greatest at the equator. The amount of energy per unit area is highest at the equator. So as that water is being pushed across the equator, it's being heated up. So we can see the thermocline is where we have a drastic change in temperature in the ocean. So we can see, because the water is being pushed across and heated up, our thermocline is very, very low in the water off the coast of Asia, off the western coast of the Pacific. So that really warm water builds up off this coastline. Warm water, again, warm water regulates the temperature of the air above it as well. So warm water means I'm going to have warm air above. The warm air above can hold a lot of water because, again, we talked about solubility increasing with temperature. So as the air warms up, now I have a lot more liquid that can be dissolved into it. So as that warm water is heating up the air, it's grabbing onto the moisture as well. But as the air goes up into the sky, don't forget, it starts to cool off with elevation change. So the higher the air warms up, higher that warm air goes, the colder it's going to become. Colder it becomes, the more rain we have. So we tend to get very wet conditions on the western side of the Pacific in normal years. On the eastern side of the Pacific, again, my thermocline goes way up because there's a drastic change in water temperature, a lot shallower depth. So over here, that water that got pushed across the equator has to be replaced from somewhere. It's replaced with cold water from below. That's why the thermocline goes way up near the surface here, and it's way down at 200 meters over here. Again, it's where the temperature changes drastically in the water. So since I have the really cold water upwelling here, it brings a lot of nutrients up with it. That high nutrient water makes it great for fish, great for food webs in that area. So again, in normal conditions, I have very cold water that's super nutrient rich, really good for fishing, really good at supporting aquatic food webs. But since it's cold water, I also am going to have cold air. And that cold air is going to be sinking from the top of the atmosphere. It's going to be dry air. Again, cold air always associated with dry. Warm air should always be associated with wet. So since it's cold air sinking here, it's going to be dry conditions off the coast of Peru. That's in normal conditions. In El Nino, for some reason, though, the trade winds are going to weaken and shift directions. So the normal direction that the winds are blowing aren't happening anymore. We can see that thermocline is going to shift. We end up having the thermocline go from where it was at 200 meters here. Now it's maybe 30 or 40 meters here. All right, there's going to be a much more cool water off the coast of Asia. All right, off the coast of Peru, the thermocline is going to go way down because now we have that warm water pushing across the Pacific Ocean and building up off the coast of Peru. So where I normally have dry conditions, I can see now I'm going to have really wet conditions because I have that warm water heating up the air above it, causing that warm, moist air to rise up. And as that warm, moist air rises up, it loses its moisture in the form of precipitation. Right? The colder air starts to sink off the coast of Asia, but since it's cold air, it doesn't have moisture associated with it. So we get dry conditions off the coast of Asia. We get warm conditions off the coast of Peru. So we see a major flip of what the normal conditions are. El Nino is all about flipping the normal conditions. Think about boys, they're crazy. El Nino is the boy form of baby. So boys are crazy and they're always just flipping stuff over. So that's how you can remember that El Nino is a flip of what the normal weather should be. La Nina is an intensification of the normal weather patterns. Girls are calm, they like to play, and they like to play in very specific ways. So whenever they're playing, they're intensifying those trade winds. So if it's a La Nina year, instead of the trade winds reversing direction, they get even stronger. And when they blow even stronger, they're causing that thermocline to go even further down and change even more. So we get an intensification of the normal weather with La Nina. Again, girls, you know what to expect. Intensification of the normal. El Nino, boys, you can expect a flipping of what's normal. And it's flipping because of changing the wind patterns, changes the temperature of the water of the ocean, which changes global distribution of the water, which changes everything else. So we can see this is going to be what's going to be. It's not just going to affect the equatorial Pacific. It's going to affect 2/3 of the planet because what we end up with is there's a jet stream that goes through the United States. There's other wind patterns that are going to be carrying normal conditions across the planet. When El Nino occurs, this changed temperature of the water changes the wind patterns as well because winds are all dictated by temperatures. As those wind patterns are changed and altered, that redistributes the heat and the moisture across the planet. 2/3 of the planet's weather is affected by it. Where it's normally wet, it's going to be dry. Where it's normally dry, it's going to be wet. So we can see, again, we look at over here, and this is lushly vegetated. Lots of jungles off the coast of Southeast Asia. But during an El Nino year, we get warmer, drier weather. So, all these jungles down in here, now they're going to be drier and warmer than normal because it's El Nino. Over here, again, rainforest jungle area, we get dry conditions, even though normally speaking, it's really rainy. So the normal conditions are changed and flipped to be the opposite during an El Nino year. And it's across 2/3 of the planet. So if it asks you to link the effects of El Nino to climate alterations, always know that it's going to be the opposite of what it normally would be. Here we usually get colder, wetter areas. Now it's going to be warmer and drier. That cold air is going to be pushed more up towards the Arctic and held there. But if we look over here, this kind of dips down. We tend to get, maybe a little bit colder air coming in across the lakes, so we see more snow in our area. It's going to flip what the normal weather conditions are, and that's what El Nino is all about. And that's it for the Unit 4 review. I hope you understood it. Again, if you guys have questions on any of it, please ask. I will gladly go over anything that you guys have on it. I would suggest watching a couple of videos on El Nino. It's a pretty important thing and pretty impactful thing. It very well may show up on the AP exam this year. I don't always do a great job explaining it, but there's a ton of good videos out there on it.